In this example, we've got a quartic equation and we're told we've got roots alpha, beta, gamma and delta. So again, what we need to do is be able to find the product of the roots, or the sum of the roots 4 at a time. Remember, that's E on A, so it's going to be the 5 over 1, which is 5, which this one's nice because it's modic, so it makes life a little bit easier. And we've got the sum of the roots 2 at a time here, which we know is C on A. We keep going back to those rules till you know them. So that's going to give us the minus 1 over 1, so it comes out as minus 1. Sum of the roots 3 at a time is the minus D on A, so it'd be minus of minus 1 over 1, which gives us the positive 1. And then the sum of the roots 1 at a time, which would be the minus B on A, so it gives us minus 2 on 1, or minus 2. So there's how you can find all 4 situations with our quartic equations and the 4 roots. So in this question here, we're told that one root is 3, so we're given a hint that one of the roots of this equation is 3, and they want us to find the sum of alpha and alpha beta, which would be the other 2 roots. So instead of having gamma in there, we're just going to have 3, which means that if we're going to have the sum of the roots 1 at a time, we get alpha plus gamma plus 3, which would be the minus B on A, which is minus of minus 5 over 1, so that'll give us 5 there. And then 3 plus what would give you 5, so alpha plus beta would equal 2. And you know that alpha times beta times the third root would give you minus D on A. So again, A is 1, minus of 21 on 1, so that gives us minus 21 divided by 3. That would give us alpha beta is equal to minus 7. So an easy little manipulation. I've done this question 2 ways, so you can use whichever one you like. We're told 2 roots of this equation are equal to 4 and 2. Now, the first way I've approached it is to say, well, if you've got a root of 4, that means when x is equal to 4, y is equal to 0. So it means that must satisfy that equation. So we just substitute 4 in there and get an equation in A and B. Done the same with minus 2, because that's a root as well. So we've done the substitution and put it in, and got another equation in A and B. And then we've started to solve simultaneously. So we've manipulated to get A is equal to minus 11 on 8 and B is minus 37 on 4. So once we got there, we've just done our simultaneous equations as we normally do. The other way to look at it is, well, if I know 2 of the roots are minus 4 and 4 and minus 2, then I can put those in to go, well, I know the product of the roots is minus D on A, so I can get an equation where I can find the third root. So if that's the case there, I can start to go, well, minus 8 times gamma is equal to 5, so the third root is minus 5 on 8. It's not pretty. The other 2 are a lot nicer, but there's the third root, which is not pretty at all there. Which means, though, that when I then look at finding, well, what's A here, what's the value of A, I can do the substitution there, that can be minus of the A on 1 would be equal to the sum of the roots 1 at a time. So I can substitute that, and I can get A being equal to minus 11 on 8. So you can see that you've got it there. And then you could do the same with the sum of the roots 2 at a time to get the B on 1 is equal to B on 1. So then you can solve for B. So you could do that the same way. You should work out. Do that. So either way you want to manipulate it and work it out, it's totally fine to do it either way, because they give you the same values for A and B. It'll work out for you. Question 5 here says x is a double root, and we want to find the value of A and the sum of the other 2 roots. So it's a 2-part question, really. Now, we keep in mind that we said it's A, if x is a root there, it's a double root, we know that we can substitute 2 in, and then we can get an equation where A is the only unknown. So you can start to manipulate and do the calculations. So they cancel. 16A minus 16A is equal to 0. A would have to be equal to 1. Also, because it's a double root, well, 2 of the 4 roots is 2. So we said, well, 2 plus alpha plus beta, that would be the sum of the 4 roots, which allows us to get alpha plus beta by itself, which is minus 2, just by doing our manipulations once we've got the value of A being 1. This one we want to find the roots, and we're told that 2 of the roots are equal. So again, what we want you to do is think back to when we did the work on the graphs. Now we know that when we did work on our graphs there, that if we had a root and it turned, so the root was actually a turning point as well, it worked out to be a situation where it would be all squared, or there would be a double root at that value. So remember that situation, that y was equal to 0, but also the first derivative was equal to 0. And that's what we've done here. To help us find this, it's hard to try and, well, you can start to play around and look at values, but they might not be nice values to get the roots there to try and work out which one's a double root. Especially seeing we've got an 8 there and a 9 there. Lots of manipulation that needs to go on. So if we go and get the first derivative, not easy to solve a quadratic. So we get down to a quadratic, and we get that if the turning points of the equation are 3 on 2 or 1/6. So what we want to do then is just take either one of them. I've taken the first one I've got there, which was x is equal to 3 on 2, and then substitute it back into the equation. Now, those are both turning points. So at the turning points there, we should see if either one's a double root, that the original function should give us 0. And I got lucky in that I put 3 and 2 in, and it worked out to be 0. So obviously 1/6 doesn't work out. You can't have two double roots in this situation. So what we need to do then is look at that and go, well, if 3 on 2 is a double root, then I know that alpha is 3 on 2, and alpha plus beta, or 2 lots of alpha, would equal the 5 on 2, which is comes from the minus of minus 20 over 8. So that's where we get that one from. Minus of minus 20 over 8 would give you 5 on 2. So we ended up being able to get the beta being the other root. Okay, but keep that in mind. If it's a double root, then at that root, which means our function would be equal to 0, we'll also get a turning point. So the first derivative would be equal to 0, so we're able to solve that way. So a nice little manipulation to be done. We saw ones like this in the 2-unit course, but this time we've got 3 roots, and it says find the roots, basically, if sum of 2 of the roots is 0. So our manipulation here is to let 2 of the roots be alpha and minus alpha, because they would sum to give you 0. So the sum of the roots one at a time, well, they will cancel each other out, and we get that'd be negative 4 on 12, which means the third root is 1/3. And then we go to the product of the roots, which means we get alpha times alpha, negative alpha, which gives us minus alpha squared, is times beta, which is the third, would be equal to the minus 1 on 2. So the negatives cancel, and we'll multiply by 3 on both sides to get rid of the third, which gives us alpha is equal to a half. So if alpha is equal to a half, the other value minus alpha would be minus a half there. So there's our 3 roots. In question 8 here, same idea, but this time we've got a quartic equation. Sum of the 2 of the roots is 0, so again we let alpha minus alpha be the 2 roots, and we've got beta and gamma as our third and fourth roots. So again, get this situation where we're adding the roots one at a time, and they'll cancel. So beta plus gamma is equal to minus 5 on 6. Then we can sum the roots 2 at a time, gives us minus 24 on 6, which allows us to get minus alpha squared plus beta gamma is equal to minus 4. Let's keep manipulating and see what we can do. It doesn't help us too much there. Then we get sum of the roots 3 at a time is equal to 15 on 6. Allows us to get a manipulation where we see minus alpha squared being factorized out, because we're able to get rid of those two because they cancel. So that leaves us a beta plus gamma, which we're able to substitute in minus 5 on 6. Gives us minus alpha squared times the minus 5 on 6. Divide by that. Alpha squared is equal to 3, which means alpha would be equal to root 3. So that allows us to get the beta and gamma equal to 18 on 6, which is 3. That's the product of the roots. Which means beta gamma is equal to minus 1. And as we could have also got that once we worked out that that was 3, or we could have put that in there and got that as equal to minus 1. So and then we can start to manipulate both of those and start to get our values of beta and gamma there. So which isn't here, but you can do the substitution of beta is equal to -1 on gamma and then solve that quadratic there in that one. So that's a manipulation you can do to get those. But notice how we've used all four to get our solutions. Oh, we didn't use the product of the, I think we did use the product of roots, so we've used all four to get our solution there. Not an easy one, because the more roots we have, the more manipulation we've got to do.